All right, guys, I'm going to do the first 9 problems on this review, and I'll probably have to splice it up a little bit just because of the fact that 9 problems will take a while. But let's do this. So I'm updating this because my first videos included the use of Desmos, which, hey, you guys will not get to use. So let's go ahead and sketch the 2 curves here from x equals 1 to x equals 3. I'm going to go ahead and start here. You can do 0 if you want. They're both going to be 0, 0. 1, 2, and 3. Remember, just a sketch. All right, plugging in 1 into the first one, I get 1 squared, 1. 1 times 6, 6. 6 minus 18 is negative 12. Plug 2 in. 2 squared is 4. 4 times 6, 24. 24 minus 36 is also a negative 12. And if I plug in 3, I end up actually getting 0. So this is a parabola. Not my best parabola. You get the idea. Okay. All right, let's try to plot this line. So this line is to start at 0, 0. And at negative 6 times 1 is going to be negative 6. Then it's going to be the same point here at negative 12. And this is going to be negative 18. So it looks something like this. And the key takeaway from this sketch is we're trying to find the area between 1 and 3. And so if you look at that area, that's this one first, from 1 to 2. And then it switches from 2 to 3 in terms of which function is on top. So really, to do this, I need to actually set up 2 integrals. The first one from 1 to 2, excuse me, where my line is on top. So negative 6x minus 6x squared minus 18x, all of that dx, plus the integral from 2 to 3, where my curve is on top, 6x squared minus 18x minus negative 6x, all of that dx. All right, so we've got 2 that we need to do here. I'm going to clean it up a little bit. So we've got negative 6x squared minus 6x. Subtract, actually, let's do this in one step. Negative 6x minus negative 18x is really plus 18x. That's going to be plus 12x. And then plus the integral from 2 to 3 of positive 6x squared. Negative 18x plus 6x is minus 12x. It shouldn't surprise you. Those are essentially the same, but just different signs, right? We change which function is on top and which is on the bottom. Always going top minus bottom. All right, so let's find the antiderivatives. Let's see, negative 2x cubed plus 6x squared, right? Evaluated at 2 and 1. And then plus positive 2x cubed minus 6x squared, evaluated at 3 and 2. All right, so f of 2 minus f of 1. Let's do that first. So it's going to be negative 2 times 2 cubed plus 6 times 2 squared minus negative 2 times 1 cubed plus 6 times 1 squared. So we'll get that answer. Plus, let's do this one here. Remember, this is the fundamental theorem of calculus, right? Doing the difference between plugging these 2 limits of integration in. So 2 times 3 cubed minus 6 times 3 squared minus 2 times 2 cubed minus 6 times 2 squared. All right, we got a lot going on here. All right, let's see if we can get an answer. 2 cubed is 8. 8 times negative 2 is negative 16. Plus 2 squared is 4. That's 24. Minus, that's going to be negative 2 plus 6. So what's that going to be? That's going to be 8 minus negative 2 plus 6 is going to be 4. So 8 minus 4 is going to be 4. Plus, that's going to be 3 cubed, 27 times 2 is 54. Minus 3 squared is 9 times 6. That's 54. That's going to be 0. Minus 2 cubed is 8 times 2 is 16. 2 squared is 4 minus 24. So that's going to be plus 0 minus 16 minus 24 is going to be a negative 8. So that's going to be 0 plus 8. 4 plus 8 is going to be 12. All right, so that was a lot of work, a lot of integrals, a lot of math. So that's number one. The answer is 12. Let's do number two. A little bit simpler. With number two, they give us the sketch, and we're trying to find the area of the shaded region. Which of these is going to represent that value? Now, when I look at this, I'm starting at, looks like this is A all the way to C. All right, and when I think about which function is on top, the entire time, f of x is on top and g of x is on the bottom. So my first thought is I need to have f of x minus g of x. All right, so this one where it kind of splits it would make me think that there's going to be some issue with the like one, at some point it's going to change which one's on the top. All right, so I'm not really understanding what that is. This one is trying to use the absolute value. I actually, if I had take a moment, and if I had done this up here for the first one, the integral of 1 to 3, the absolute value of negative 6x minus 6x squared minus 18x dx, this actually would have given us the same value. All right, well, we couldn't do that because we don't have a calculator, so we had to split it up. So absolute value is when I'll use that when I'm looking at some kind of change in terms of which one's on the top or which one's on the bottom, but not going on here. And so I just need to make sure f of x is on top. So that's first. So this is going to be D, the top minus the bottom. And that's the key takeaway for this one is top minus bottom. Okay, let's do number three. What is the area of the region between the graphs of x squared from 0 to 2 and y equals negative x? All right, so 0 squared is 0, 1 squared is 1, and 2 squared is 4. So I'm going to graph this. Okay, plotting my other line, I've got plugging in 0, I still have 0, 1, negative 1, 2, negative 2. So what you should notice about this is the entire time from 0 to 2, one function is on top of the other, right? So this is what I'm looking at here. The entire time, my curve is on top of my line. So when I set up my integral, I'm just going to go 0 to 2 of the curve, so x squared minus negative x, all of that dx. Clean it up a little bit. So x squared plus x. All right, let's do the antiderivative. That's going to be 1/3 x cubed plus 1/2 x squared evaluated at 2 and 0. And I like this because since I don't see the exponential function, all right, the natural exponential function, that letter e, and I see a 0 with just x's, I really only need to plug in 2. So I plug in 0, I'm going to get 0. Subtracting 0 is not going to change anything. So I'm just going to plug in 2. So I get 2 cubed, which is 8, so 8/3, plus 2 squared is 4, which is 4 divided by 2 is 2. Getting common denominator is 8/3 plus 6/3, which is 14/3. That's the answer for number 3. All right, let's keep going. Remember, we're going all the way to 9 for this one. Okay, the area of the region in the first quadrant that's enclosed by these graphs, a cubic one, and a line. So let's do 0 cubed plus 8. So there's 0, 8. 1 cubed, 1 plus 1 is 9. And then we have 2 cubed, which is 8, plus 8 is 16. So we're going way up here. Right, and if you remember back in your days of algebra, that's what it would look like. Don't really care about that since that's not in the first quadrant. Let's graph the other one. 0 plus 8 is 8. 1 plus 8 is 9. So we've got the same spot here. Okay, and then 2 plus 8 is going to be 10. So I can do a little bit lower. I'll try my best to do this here. So essentially, all right, it's kind of hard to tell. Let me redraw my curve as well. Okay, something like that. Okay, now I think it'll be easier to see. With my line, I need to hit here, right? with my line like this, what you're going to see is that there's only a tiny little part right there where they actually have an area that's enclosed, because as I move past 1, the cubic function is going to be always above the linear function, and it's not going to actually enclose any area, right? These are going to keep going forever. So it's not going to actually be able to be calculated. So the only one I can calculate is the integral from 0 to 1. And my line, x plus 8, is actually on top of my cubic function, x cubed plus 8. So this is what I'll be calculating to find this area. Let's clean it up a little bit. So I've got negative x cubed, and I've got plus x, and 8 minus 8 is actually 0. So I'm going to do the antiderivative of negative x cubed, which is negative 1/4 x to the 4th power, plus 1/2 x squared, evaluated at 1 and 0. Again, I'm excited because I don't see the letter e, right? Don't have any exponential function, so I'm going to write f of 1 minus f of 0, but I'm really only plugging in the number 1. So negative 1/4 times 1 to the 4th power plus 1/2 times 1 squared, which gives you negative 1/4 plus 1/2. Getting a common denominator is going to be negative 1/4 plus positive 2/4, which is positive 1/4. That's it for 4. Let's do 5. Okay, so 5. 5 is asking, very similar to number 2. We've got this sketch, and we want to figure out which of these would represent this, okay? So what I notice is I've got A to B, all right? So I'm looking at that first. And then it looks like I have my line right here, y equals d, is on top the entire time, and my function is below. So I'm thinking it's going to be b, right? The integral from a to b of d minus f of x. Now, I want to talk about a for a second. If this area had also been included, right? It's not, right? It's a gap there. But if that area had also been included, then letter A would be okay, because you can also integrate with respect to the y-axis. So the integral from these limits of integration of our function written as f of y as opposed to f of x. So we're going to do that a little bit later in some of these problems where we have to rewrite our function. All right, so the answer for 5 is B. Okay, let's do 6. There's our natural exponential function. Here we go. So let's plot it. So it says the line x equals 2. I see that over here. So here's x equals 2. Let's plug in 0. E to the 0 power is 1. Let's plug in 1. E squared. So E is 2.7183. Squaring that, it's going to be greater than 4 but less than 9. So, somewhere up here. You get the idea of what's going on. All right. And the key thing I notice is that there's no gaps here, right? This is the area that's created. So I'm trying to find that. The integral is from 0 to 2 of my function e to the power of 2x dx. Now, when we did this with derivatives, you want to first copy it down for the antiderivative. And remember, when you take the derivative of the natural exponential function, you copy it, and then you take the derivative of the exponent. The derivative of 2x is 2, and I don't want to have a 2 here, right? There's no 2 there. So I need to do the reciprocal of that, which is 1/2. So that is my antiderivative. Now, before the last couple, I've been saying how excited I was to see 0 because I don't need to worry about plugging it in. Unfortunately, here I do need to plug it in because e to the 0 power will be a number. So don't forget that when you see that letter e, it's going to be a little different. All right, so we have 1/2 e to the 4th power minus e to the 0 power is 1. So minus 1/2. So I'm looking for my answer, that this is it. And it looks like what they've done is they've moved the e to the 4th power in the numerator. All right, so the answer is C. Okay, 3 more to go. All right, now number 7. I like number 7 because they give us the actual sketch, but it doesn't tell us what this ordered pair is, right? I know this is 0, 0, and I just don't know what that is. So let's go ahead and set 5x minus x squared equal to 2x, and we'll solve for it. So moving this over, I get x squared. 2x minus 5x is negative 3x. All right, we're going to factor, and you get x equals 0 and x equals 3. So I know it's 3, And you can plug that 3 into either one. It will be the same. The easiest one to plug it into is this x. 3 times 2 gives you 6. All right, so the area of the shaded region is going from 0 to 3. And the entire time, my parabola is above my line. So I'm going to do 5x minus x squared minus 2x, all of that, and then dx. So this is my integral that I'm setting up. Let's clean it up a little bit. We have negative x squared. 5x minus 2x is 3x. All right, antiderivative is going to be negative 1/3 x cubed plus, this is going to be x squared. All right, so we want to put 3/2 in front there and then evaluate it at 3 and 0. We're back to getting excited when I see that 0 because I don't see the natural exponential function. So f of 3 minus f of 0 just means I'm going to plug in 3. So negative 1/3 times 3 cubed plus 3/2 times 3 squared. That's going to give me negative 9 plus, that's going to be 9 times 3 is 27/2. Get a common denominator is going to be negative 18/2 plus 27/2 is 9/2. So for number 7, the answer is B. All right, 2 more. So number 8. Number 8 says the region in the first quadrant bounded by the lines x equals 1. All right, so 1, 2, 3. So x equals 1 and x equals 3. So I'll put those down. Those are vertical lines at 1 and 3. And we need to plot our function e to the power of x. So that's going to be 0, 1, 1e, and then it's going to just keep moving. Something like that. And then if I plot my line, that's going to be negative 1. And then plugging in 1, you get 0. 2 is 1. 3 is 2. So it's never going to get above my other function. All right, so I'm trying to find this area that's in between them. And the entire time, my exponential function is above the linear function. So the integral from 1 to 3, right, e to the power of x minus x minus 1, all of that dx. Okay, let's simplify if we can. E to the power of x minus x. Subtracting a negative 1 is actually plus 1. I'm going to do the antiderivative of e to the x, which is just e to the x, minus 1/2 x squared plus x, evaluated at 3 and 1. So let's do f of 3 minus f of 1. So I have e cubed minus 1/2 times 3 squared plus 3 minus e to the first power minus 1/2 times 1 squared plus 1. All right, what I would encourage you to do is make sure that you are dealing with the whole numbers or fractions at first if you can. So in this case, I see that I have, let's see, it's going to be 3 squared, which is negative 9/2 plus 3. And then minus, that's going to be negative 1/2 plus 1, which is going to be 1/2. So if I do negative 9/2 minus 1/2, that's negative 10/2, which is negative 5, and negative 5 plus 3, which is a positive 2. Or excuse me, negative 5 plus 3 is a negative 2, my bad. So I'm thinking it's going to be B because I see that negative 2. Let's see what other things I have. I have e cubed and I have e. So yes, my answer is going to be e cubed minus e minus 2, so letter B. All right, so you'll see that later on in other questions that I try to deal with the whole numbers first to help me narrow down my answer choices. Okay, last one. Number 9. Number 9 says, let our region, R be the region in the first quadrant, bounded above by the graph 7/3 x plus 1. Let's graph this. All right, so 7/3 x plus 1. That's going to be 0 plus 1, which is 1. There's 1. Let's do 2. We'll do 3. Okay, so plugging in 1, I get 7/3 plus 1, which is going to be 10/3. So something up there. It's just going to keep progressing. Something like that. And there's just a sketch. Okay, it's supposed to be a line, not the best line. Let's try graphing 2 to the power of x. So on this one, I've got 0, 1, all right? 2 to the first power is 2, so going to be lower than that one. 2 squared is 4, so still lower than that one. And then here's where it's going to be the same. Right? When I plug in 3 for this line, I'm going to get 8. When I plug in 3 for this exponential, 2 cubed is 8. So they're going to hit right up here. Okay, so this is my area. And I'm trying to set up integrals that would make sense. So 0, 1 is that ordered pair. And we said this one was 3, 8. So I think everyone's going to be good on Roman numeral 1 being correct because we've been doing top minus bottom, right? Top minus bottom. And the function on top is our line, 7/3 x plus 1. So that is top minus bottom. The limits of integration are correct, so we're good there. Now, when you look at Roman numerals 2 and 3, this is where we're actually going to be taking an integral with respect to the vertical axis. So when I do the vertical axis, I'm actually thinking right minus left. Okay? So if you move from the y-axis, the farthest function on the right is actually this exponential function, and the one on the left is the line. So if I rewrite each of those with x equals as opposed to y equals, I can figure out what that integral would be in terms of using dy as opposed to dx. All right, so let's do it's 7/3 x, so y equals 7/3 x plus 1. So let's move over the 1 with subtraction. Then to get rid of the 7/3, I multiply by the reciprocal, 3/7. So that doesn't surprise me. That's what I got there in both Roman numeral 2 and Roman numeral 3. So that's confirmed. Let's do the same thing for y equals 2 to the power of x. I'm going to take the natural log of both sides. I'm going to move the x in front to get the natural log of 2. And then to get x by itself, I would divide by the natural log of 2. So again, shouldn't be surprised. You see that in the, did I write x? Not really good. In the first one, all right? Because that is our function on the right. Our exponential function is on the right. So the only question is, everything is the same except for the limits of integration. And when you do an integral with respect to dy, you want to make sure you're using the y coordinates here. So the y coordinates here are 1 and 8. So that's why Roman numeral 3 is also going to work. So the answer is D for Roman numeral 1 and 3. All right, so that's it for the first 9. Check out my other videos for the rest of them.